Yeah. So today that I would like to present 智慧制造工业4.1 Intelligent Manufacturing and Industry 4.1. Of course, you will be surprised why everybody say Industry 4.0, but I'm talking about Industry 4.1. Of course, then if I would like to exceed Industry 4.0, then I need to have the capability to accomplish all the goals in Industry 4.1. So anyhow, I should say all the technology required in Industry 4.0, I can achieve it. But beyond that, I will exceed that to be more, to not only accomplish the goal of Industry 4.0 and try to beyond it to achieve the state of zero defect. Then I'll see what's going on here. So, okay. So, to begin with, then I'll introduce what, actually, in order to do this kind of mission, I need a research center. So, in NCKU, we established an Intelligent Manufacturing Research Center, IMRC, and I will introduce that first. Okay, so what is IMRC? Okay, so it's the introduction to IMRC. So to begin with, I would like to tell you the importance of quality and the vision of Industry 4.1. You see, Industry 4.0 values productivity but overlook the importance of quality. You see, when Germany brought up the issue or tried to promote Industry 4.0, they said that if you use the Industry 4.0, they can increase the productivity for 20, 30%, etc. But they didn't mention about how to improve, how to enhance the quality of it, right? You can check it. So why that is the case? Just because he cannot guarantee the zero defect of the product. But because if you would like to make sure that your product has no defect, that is the primary goal of production. But you see, they cannot guarantee that. Why? Just because they don't have a very efficient way to do total inspection. In order to guarantee zero defect, you should be able to have a very efficient technology to do total inspection. But they don't have this kind of technology, so they cannot guarantee the zero defect. But we can do it. So all the technologies of Industry 4.0, for example, IoT, cloud computing, cyber physical system, big data analytics, we can do all of them. And besides that, we can do a total inspection with our technology called automatic virtual metrology. So that is the reason why I said I can be beyond Industry 4.0 to achieve the goal of Industry 4.1. And I will let you know the importance of zero defects. About 3 years ago, you see, the Samsung Note 7. If you remember, the Samsung Note 7, their cell phone, they produce about more than 4 million cell phones. But you see only about 20 sets burned because of the battery. So that's some kind of defect there. So the product just failed, right? So you see the customer really want is the product that they purchase has no defect in it. They don't care in your production factory, the health status of the tools or how is the scheduling working. They don't care. What they really care is the product that they purchase has no defect. Okay? So zero defects is the most important thing for production. But you see, Industry 4.0 didn't define that. Then I define this one. So I call it Industry 4.1. And in order to do so, of course I need to develop a platform that can not only accomplish the goal of all the Industry 4.0 want, but also have the total inspection capability. So you see, just as what is said here, so by integrating the intelligent service such as automatic virtual metrology, intelligent predictive maintenance, and intelligent yield management, And I need to have a platform called Advanced Manufacturing Cloud of Things. This one is something like MindSphere of Siemens, right? So we need to have a platform to do all of the cloud manufacturing, cloud computing task for Industry 4.1. So you see, using this kind of platform, then the goal of zero defect can be achieved. So this Industry 4.1, actually it's been defined. I have already defined this one and published this in IEEE journals 3 years ago, okay? And I use weird machining automation as it. So Industry 4.1 is not just I brought up today. I have already have this idea 3 years ago, okay? So see, and my in the Intelligent Manufacturing Research Center, what we try to develop is an intelligent manufacturing system framework. So you see, intelligent manufacturing should be good for all kinds of industry, not only for example, semiconductor or CNC machine. It should be versatile, should be applicable to all kinds of applications. For example, shown here, so the application line, production line application we can use in semiconductor, TFT LCD, aerospace, CNC machine, etc. So you see, what we really develop is a platform called Advanced Manufacturing Cloud of Things platform. And this platform, you see, my center, because I would like to do the intelligent manufacturing, then we need to know what kind of technology are required for intelligent manufacturing. So you see, we have 4 centers. One is called e-manufacturing. Actually, that e-manufacturing, did you remember, semiconductor industry has the concept of e-manufacturing about 15 or 20 years ago. So I have established an e-manufacturing research center about 15 years ago in NCKU. So you see, in here, so why they just introduced me as semiconductor automation godfather, because I do semiconductor manufacturing automation 20 years ago. And you see, all of these kind of technologies try to do, for example, they call it engineering sim, equipment engineering system. So all of the system integration technologies are built here. And this one has something to do with AI, robust optimization technologies. So I have division. They are digging into the technology of AI, technology of robust optimization. And this one is something to do with ICT technology. For example, for big data, cloud platform, and for AR, VR technology, machine learning, etc. And here is 3D printing. Because you see, the 3D printing is the manufacturing technology in the future. But you see the 3D printing, they encounter some kind of difficulties. After you have the 3D printing, right? If you would like to know how good it is, does this satisfy the requirements, then you need to wait until it finish all the production. Then it move to the measurement machine and to measure it to see how good it is. But it's too late because you find something wrong. It's too late. You need to throw it away. You need to do it again. So what we really would like to do, we need to have a coaxial CCD camera and to do it. And we will use our automatic virtual metrology system to do online real-time feedback so that we can have really feedback control in online feedback control. So in other words, it's in situ metrology for for the 3D additive manufacturing. This is one of the technology that we are focused on. So you see, our system, we have already developed this kind of framework. And this framework, you see, has been implemented in various kind of industry. You see here, very first one, that is for ASE Group. I can show you that last year they said they would like to emphasize AI, how to use AI to for their industry intelligent manufacturing. So you see, actually, I implement this in ASE group, and it's a very good success. And I implement AVM, year management, and predictive maintenance. And I will show you how to do it. And next one, this is for Mosa Plastics, 就台塑碳纤. So here is, and this one is for Femcom, 远东机械 for wheel machining automation. And I will come to that in details. And the next one, that is for Cheng Power, that is for bottle industry. So you see, I just showed typically these four. Actually, I still can do the others. For example, for the AIDC, for the engine case manufacturing, for the aerospace applications. Okay, so you see, so the mission of IMRC, what to do? Okay, the very first one is our IMRC is dedicated to assist various manufacturing industries to realize the vision of Industry 4.1. Then how I can do it? The concept is something like that, because I have a automated virtual metrology technology, and this technology actually has 6 countries patents. Our Taiwan, US, Korea, China, Japan, and Germany. So I can show you, and because of this kind of automatic virtual metrology technology, we can achieve the goal of having 0 defect of all the deliverables. Why I say so? If you have 100 pieces of raw materials on production, okay, then I use the automatic virtual metrology technology to do the total inspection. Then after this total inspection, we find out, for example, we just have 88 can meet the specification. Okay, in other words, we have 12 have defects in it. Then those 2 defects, you need to throw it away. So you just deliver that 88 because you have total inspection. So that 88 has 0 defects. So the phase 1, we can accomplish the goal of having 0 defects all the deliverables. Then you have 12 defects, right? Then these 12 defects, because I have already established the infrastructure of big data collections, right? So the Industry 4.0's requirement. Then after collect all the big data, and I have intelligent yield management. So using the big data analytics, then you see those 12 defects, I can use big data analytics to find out the root causes of these defects. And after finding it out, I can do continuous improvement. So you see, doing data analytics and continuous improvement, I can find out the root cause of those 12 defects. Then after finding out that and doing continuous improvement, so you see the yield will increase from 88% to 92, and next one to 95, until 100% 0 defect. So that is what I'm doing. So you see, then, so I'm sorry. And I just would like to tell you that the platform that I invent, you see, that is automatic manufacturing cloud of things, won Best Paper Award in IEEE conference. So what is this one? You see, the key component of that is we have an IoT device called Cyber Physical Agent. Actually, I have this patent about 15 years ago. At that time, they didn't call this IoT device, but actually this is the IoT device. Not only can collect various kind of data. If the semiconductor industry, I use SexGem interface A. If for CNC machine, I use OPC UA, empty connect, etc. Right? And I can do edge computing here. Right? So this is a very key component to do IoT. So next one. So you see, in order to do so what we call intelligent manufacturing, then you see we have a production line. For this example shown here is semiconductor process. So it's a bumping process. Just have this golden board on the chip. So you see we have process data, metrology data, and inspection data. So the very first step is, of course, you need to have all the sensors data there. Then what you can do, the very first things you need to do, of course, is IoT. You need to collect all the data, web-wide, right? The IoT can do so. Very kind of data, not only process data, but also the metrology and the inspection data. After collect all the data, then what to do next? Send it to the cloud. Okay? So this is the cloud. A cloud of things, that is the AMCOT. So on this cloud, we have relational database and the Hadoop database. We can do big data analytics. And you see all kinds of smart manufacturing functions. For example, the automatic virtual metrology, run-to-run control, intelligent predictive maintenance, and intelligent yield management can put on the cloud. And this cloud can be Zhonghua Dianxin's high cloud, or Microsoft Windows Azure, or Amazon's AWS. I have already tested all of them. Okay, and then, so next one. So you see this platform has been tested for various industries. And I just show 5 of them. The very first one is the semiconductor industry, then aerospace and chemical, that is the carbon fiber, and automobile, that is wheel machining, and the bottle industry. Now I'll show you one by one. Okay, the very first one, the semiconductor industry, the bumping process. So you see, you said it's been implemented in SE. So you see, collect the data, send it into the cloud, then implement all kind of smart functions there. Okay, and you see, just because of time, I don't have that much time to show all of them. But you see, this is in last year, in August, and you see, this is the vice president of SE, and you see I'm here. So those are the officials of most, and because they are so happy about this technology, help them to maintain #1 in packaging. Okay, and next one. Okay, so aerospace, the aerospace that is for AIDC, 就是汉翔. So you see what is aerospace here. So the AMCOT platform, then we not only can do all of the smart functions, but also we can do automatic model creation, something like that. So just because of, I don't have that much time to explain this in details, but anyhow, what we can see is something like that. You see, this is AIDC, that is, so here, this is in Gangshan. So we have so many CNC machines. And you see here, we have CPA, collect data, and send it to the AVM server. And then we can send it to the data center in Taichung. Okay, that is AMCOT's platform. Okay, so this is another success. And then you see, that is the president of that. I show how to do the virtual metrology in their fab. Okay, and then for carbon fiber process, that is 台塑碳纤. So you see what we can do here. You see the same. The production line is about 1 kilometer long in Mailiao. So by the same technology, you see, I use my IoT to collect all of the data and send it to the cloud. And their cloud is in Renwu. Mailiao is the middle part of Taiwan. Renwu is in down south Kaohsiung. So you see, this is the cloud manufacturing. Okay, so the AMCOT. And then next one. This is for carbon fiber process. This is a continuous process. And I still can do, for example, AVM, IPM, etc. Okay, so various kind of smart functions. Okay, then the wheel machining automation. That is for automobile industry. And I'll show you what we have done about a year ago in INT Duo webcam. Okay, so you see, conventionally, for this kind of weird machining automation. So you see, we will have, this is just the RC is something like that. Hmm? 不会动。Okay, I'm sorry. Okay, so RC is something like that. If you would like to do smart manufacturing or Industry 4.1, then what we should do is, you see, yeah, we need to install the sensors, and we do with tracking and send it to using the IoT to collect all the data and send it to AVM server. But this AVM server can be in the cloud. If we would like to send it into the cloud, then what's going on is something like that. So you see, shown here, using CPA, collect all the data, send it in the cloud. Because Facom, 远东机械, he is a vendor. He sell production, I mean CNC machine worldwide, and those are their customers. And what we show here, their customer in Thailand and doing machine manufacturing. And this is cloud is using a high cloud, 中华电信 data center is in Taipei. Okay, and he can do this kind of manufacturing. Okay, now I'll show you. You see, collect data here. Try to collect data in Thailand, send it to Taipei's data center, and shown in Taipei Nangang. Okay, so what's going on is showing here. Okay, after this, we exchange the raw material into OP1. Then after finish it, then he will have the AVM value shown here about right away. So because I don't have that much time to show all of this one, and this is the reality. Now it's in Thailand and has this kind of factory working. Okay, so next one. Then you see, because what we really would like to do is to make sure that every piece of it, we have the quality. You must check all of them, because use virtual metrology after finish production. Then all of the quality data being collected and being installed in the cloud, something here. And we will use laser marker to mark it, a QR code here. So if you would like to know the quality of this wheel, just scan it, and you can have all of the quality data here. So I can guarantee that this has zero defect to the customer. So I can achieve the goal of zero defects. That is the goal of Industry 4.1. Okay, so see, and President Tsai Ing-wen visit our booth, and I show what's going on here. Okay. I'm sorry, this is in Chinese, but it's very interesting.
我们已经要建构中华民国第一个基建营。那这个营收平台是像这个基建营里面，我们这里面像有那个就好像有登机舰，我们把它整个搬来南港，而且我们可以连到泰国去，实际上里面连到泰国去，然后泰国的客户，还有都是连到华国那边可以连，证明说，而且这个high cloud怎么回事呢？这个其实我们自有营中华电信政府董事长找我们合作，所以就说high cloud没错。那我们这边做出来，这里面它high cloud上面的波程本去，总共有连到南港，就在这边，连到泰国，连到花德，就在嘉义。那我们这边都有这个智慧化的应用，我们这边不但有所谓的旗舰型的智慧基站盒，别人基站盒顶多能够做到可视化。我们这个基站盒可以做到智慧化，意思就是说，他们顶多把资料抓出来，我们不但抓出来，而且可以做各种智慧应用，像这里面的 AVM， 就是全自动虚拟量测、预测保养，而且整个都建构出来。本来可以 demo 整个产线，但现在因为门都挡住了，像这边如果加完工以后，立刻就会秀出来。所以我们中华民国本身就能够做到工业4.1，因为我们就可以做到前检。资料填写是第一，完整。 接下来，蒙一后开分钟题。那现在的话，我们这产业的话，它
请问月租费13000一台机台，对。
而且
对。
智慧化，而且我们这边还重要讲说，我们这边是智慧机上盒，我们可以做到什么样的程度？像说你要接第4台，你要跟家买上盒，他帮你把网路线拉起来，你付钱多，服务就多。我们也一样同样的观念，中小企业也一样可以，我们用云端帮中小企业的所有机台全部做智慧化服务，包括全自动清理量测，包括预测保养等等。
So you see, so it's a reality, and I'll show you how to do it, the business model.
对，没错。那我们刚好跟中华电信开可让他主动跟我们合作，所以我们一定可以把这个做起来。
对。
Okay. So see, then bottle industry. So I will show you even more advanced technology using the cloud computing. Okay, so you see, and this is the bottle blow molding machine. Okay, so and this one, we have infrared for heating. So we need to have a temperature sensor here. And this is just for blow machine. We have a pressure sensor here. So using this back off for data collection. And now, of course, we need to collect all of the data, even the CPA, okay, and send it to, okay. Now, you see the same philosophy. And this one is demoed in last August in Nangang also. So you same. So you see, it's using the high cloud, using Chonghua Dianxin's high cloud. So you see, again, they didn't install any servers in nearby. All of the servers are in the cloud. Okay, so you see, and totally they have a lot has 8 bottles. So the speed is very fast. Every second, he can blow 5 bottles. So it's so fast, then how can you do automatic virtual metrology in real time? That is a really challenging, and we solve that using cloud computing. Okay, so you see what's going on. And you can see here. So he can have total inspection in real time. All the bottles, the thickness of the wall, he can detect it. Okay, so just because of cloud computing, I can use several virtual machines simultaneously and can do it in real time. Okay, so not only this, then later I will show this how to use this one to do run-to-run control. Run-to-run control, because the thickness of that is very important, and we need that we would like to let the CPK of that thickness is just like a straight line. So how I can do it? Let me show you. Okay. Okay, and we not only can do AVM, but also the intelligent predictive maintenance. And this shown is for the linear bearing. Okay, so just because of time, anyhow, we still can do intelligent predictive maintenance and to predict their residual life, remaining useful life, and to see to prevent unscheduled down. Okay, and and you see the vice president to visit our booth, and I help them to get the biggest award, the Smart Machinery Award. Okay. And you see, let me show you how I can do run-to-run using AVM in the cloud. Okay? So you see, previously, if you like to do run-to-run, you need to measure it. Then you can have run-to-run control like it. But you see, it's too fast. You cannot have measure all of them. You cannot do total inspection. If you would like to do the total inspection, then how can you do it? You can use the AVM to get the others. So you see, then what's going on here? Okay, so you see, this is the case. You see, because this kind of measurement machine is very expensive. In order to cost down, we just have 5 or 4 machines to share the measurement machine. And all of the AVM functions and run-to-run functions are put in the cloud. So they just need a cable, internet connections. And you see what's going on here. You see, the very first one is start. I just use one machine to show it and try to measure it. Then you see the correct data and send it to the cloud, to the AVM to check that. You see, to check that all the quality is good. If the quality is not good, then you see, we will check it, the second one. If good, then I just use AVM to check it. That's good enough because judge if the process deviates from the target. No, in other words, it's good. So don't activate run-to-run yet. So I just try to use the AVM to check the quality. That's good enough. But you see, now, okay, it's been deviated. Then I need to activate the run-to-run. Then how I can do it? So you see, when I do the run-to-run, you see, then the AVM value will send to run-to-run, and he will give you the data to change the recipe, right? So, and if the next one is still no good, then I need to use run-to-run to check it again, to correct that again, okay? Then if this is yes, in other words, it's back to normal, then it's not necessary to activate a run-to-run. And it's just doing normal AVM check. So you see, this is just one machine. If we have totally 4 machines together, then what you can do? So you see, let me show you. It's all 4 machines together. Then you can check here. So it's something like that. Machine 3, machine 1, machine 2, simultaneously do it. So this is the cloud manufacturing. This is the intelligent manufacturing. This is what I call a real implementation of Industry 4.1 that use cloud computing to do all of them. Okay? So I think this is a very, very good example to show how to do intelligent manufacturing. Okay, then you see, this is the real data that I can control the sickness, okay, back to the target. Okay, now I just show you that this is not just alpha or beta test only. It's a vigilance model because we have a IFA, Intelligent Factory Automation Alliance. So the member has Zhonghua Telecom. IMSS is from FECOM, and IMRC from NCKU and Foresight. Okay, so what's going on here? Okay, so you see this IFA framework, we have IoT device and we have a big data platform. This is just for server-based, not in the cloud. But if you would like to be in the cloud, so you see this is the one. You see Zhonghua Telecom's IoT platform is here. He can take care of high availability, take care of security issues. So you see, we just demo it. So this is a real implementation. We have a business model to do so. So you see how, so IFA's main features and benefits. So you see, I just say I have achieved the goal of Industry 4.1. In order to do so, I need to accomplish all the goals of Industry 4.0. Then beyond that, I can have automatic virtual metrology and to achieve the zero defect. So you see, the very first one is is IoT. Then is cloud manufacturing. Then IoT, the security operation, and high availability, etc. And of course, then this is the smart machinery functions for management. And then automatic virtual metrology for total quality inspection. Then that is for intelligent predictive maintenance. And then the tool life management. And then yield management. And all of the functions, just this is what Industry 4.0 called the cyber physical system or big data analytics, right? And all of them, the purpose of that is try to achieve zero defects of all the products for Industry 4.1. So that is the goal. That is the real power. Okay, so you see the business model. For example, I present to our president, Cheng. You see, you just need to have a CPA connected to your machine, not only traditional CNC tool or semiconductor equipment. After collect all the data, IoT, send it to the cloud, then I can have, for example, a semiconductor industry or CNC machines industry. I can have various smart functions in the cloud for you. Okay, and this one is a business model, you see. So the IFA, the Intelligent Manufacturing Cloud Promotion and Operation. So Zhonghua Dianxin, the mission is for marketing promotion. That is our first tier support, you see. So here, and then we have IMSS and foresight technology to the sales support, etc. And for maintenance, tier 1 is Zhonghua Telecom. Tier 2 is IMSS and foresight technology. And tier 3, if they have new requirements of intelligent functions, then I will implement it for them. So that is in NCKU's IMRC. Okay, so you see all of this one. You see this very first month of that cover of Taiwan Machinery Monthly is our system architecture. And you see, Jingji Zhibao in last year has already issued these functions. I have the technology to lead the industry to achieve the goal of Industry 4.1. And you see, and in April, I have go to Germany for Hannover Messe, Hannover工业展 to promote Industry 4.1. Okay, and finally, you see, it just last week, Zhonghua Telecom published an issue, a news, say something like 智慧制造营, that is the intelligent cloud manufacturing to assist various kind of industry to meet the goal of Industry 4.1. Thank you.
Thank you, Professor. Ladies and gentlemen, let's have a round of applause for Professor Cheng.
Okay. Now,
thank you, sir.
Next one.
And Professor, please join the rest of the guests.
Okay.
Oh, are you expecting questions?
Yeah, sure.
Any question from the audience? It's a very precious opportunity. If you have any question for Professor on this topic, feel free to raise your hand. Or if you're a little bit shy, that's okay. You can talk to Professor over there.
Okay. Yeah, I'll be around. Don't worry.
Okay. Thank you, Professor. Thank you very much.
Yeah. Thank you.
All right, and next, let's hear from the industry's perspective. Our next keynote speech is brought to you by the company Intelligent Manufacturing Solutions and Services. And I know that today the CEO, Katie, is here with us. Katie, where are you? Would you like to stand up and wave your hand? Thank you for joining us this afternoon. All right, and now let me invite our speaker, Ms. Jinglun Ko, Section Manager of the company.